Well, you know, what I did is I learned to run the jig boring machine and the Monarch 10EE lathe. Learned a lot of tricks, and I shared many of those tricks with you. And I revealed the big secret of precision that would be whispered amongst generations, I guess. But it was published by Kennametal in the Romicron boring head system. It describes a two-step finishing process, but it's actually three. You have to prepare the work for the two-step. I'll get more into that. I probably already had. So what happened is I learned to hold close tolerances on the Monarch 10EE, and to do that, I had to learn to grind tools to suit the work and the material, rather than attempting to have every carbide insert in the world on hand. So I learned to do these things on these old-time machines. And what happened is I come back to the engine lathe and the horizontal mill there. And I used those techniques, I brought them back. And I can show you some improvement by using those techniques on the Axelson here. And a simple one is, if you're looking for the best accuracy out of a lathe, the old guys, it's not just me, but the old guys have found that the most accurate work holding adjustable device is a 4-jaw chuck of the smallest diameter possible. I don't care if it's a Monarch 10EE or a hard inch, I've heard the same thing. Now, as far as, I'll get off on the hard inch a little bit. The hard inch runs a hard inch 5C collet better than a Monarch 10EE with its adapter. Okay, so if you want to run 5C collets, I recommend the hard inch. Though the Monarch 10EE will run them just fine. Okay, if you true up your collet chuck, if it needs it, or have an adjustable for true collet chuck like I built. Okay, so we found on the Axelson accuracy of rotation. Now, that is separate from spindle taper runout, spindle face runout, spindle runout. What accuracy of rotation is the bearings themselves and the part that they produce. And I've done, on this video, I'm going to do some accuracy of rotation test with the machine using the 3-jaw chuck and the 4-jaw chuck, and plus I adjusted the rear spindle bearing a little bit more tight on that. And if you do that, you play with these spindle bearings, go very, very slow. I mean, I've gone weeks adjusting these bearings, and I think I got them exactly where I want them. So I've taken the techniques, the advanced techniques to get the most out of the Monarch 10EE lathe and the more jig boring machine, tool geometries, knowledge, feed speeds, what you can do and what you can't do, and I'm reversing it back through the regular machines, okay? So I did a rotational accuracy test and made some corrections and did the test again. And I'm quite satisfied with it. Now I know that I can use this Axelson for reasonable precision bearing fitting. Okay, so we'll run the rest of the video Man, it's been a long day. I've been really going at stuff, and I hope you guys are having a great time in your shop. I really do enjoy the time I can spend in here, and I've kind of got a little bit of time I can put in here right now before I go on vacation. So, and I gotta go on vacation. You know, it's very important to me to go on vacation. So anyway, I will load this video, and we'll go from there, okay? Okay. When I talk about close tolerance work, it's all related to fitting ball bearings, and I'm talking expensive ball bearings or not so expensive ball bearings and expensive objects. You know, a $5 or $10 ball bearing can destroy an engine worth several $1,000s. So I take ball bearings and other bearings, bushings, and alignment and stuff very seriously, because you can just absolutely ruin your business by not paying attention. I had formal training from Torrington, Timken on fitting bearings at an unexpected place, and that's the Harley Davidson Motor Company. Now, if you think about it, Harley Davidson for years and years and years used Timken bearings on its wheels on the motorcycle, and also Timken bearings on the left-hand crankshaft drive end, up until, I don't know, sometime in the 2000s. They went to a needle bearing. So the motorcycles are full of Torrington needle bearings and Timken tapered roller bearings. So what I'm talking about here is rotational accuracy of the lathe. Now, the rotational accuracy on the Monarch 10E is around 30 millionths of an inch. And on Timken bearings, that's a ball bearing spindle, and on Timken bearings, you have more metal-to-metal contact, and it's harder to get that kind of precision. So you're looking at somewhere around 50 to 60 millionths of an inch run out on a really good Timken bearing spindle. And I had exactly something like 65 to 70 millionths. It was tested with a Sheffield machine by a company that was looking for someone to do work. The guy that got the job did it with a 16-inch south bend because of the plain spindle bearings. I forget what his accuracy of rotation was, but it was significantly better than half a tenth. So you're looking at a grade 9 bearing, and they say the maximum, I mean complete maximum, you can be out on a shaft or something is 2 10,000ths. And that's like, I would feel more comfortable with 2 10,000ths stacked up error than 2 10,000ths error in each component. You know, that you know, you got the shaft in the pocket. You know, you can really cook a bearing pretty easy. So what I'm looking at here is accuracy of rotation out of an antique Axelson lathe. And I'll show you where I'm at right now and my thoughts on this, okay? So this is just a field check. The best way to do it is on a surface plate with the V-blocks. But I have a fairly good substitute, a V-anvil micrometer. Putting it on a V and bringing an indicator down on it helps you more pinpoint the problem. But we can more visually see the problem here if I use this dial snap gauge. So let's put the dial snap gauge on here, and let's see where we're at with this. And I'm going to check it at 120 degrees here. So I'm just going to roll this thing up like that. Up. I'm going to get it close to the chalk. And when you're gauging something like this, you wanna do it for a while. That'll help burnish down the fuzz, or burnish it yourself with a burnishing tool, I suppose, or something. Okay, now I'm gonna call that. I don't think I have. I might have to put the camera on a tripod to do this. Yeah, I'm gonna have to do that. Be right back. Okay, we'll see how we're looking there. I think I'll be okay with that. I'll get the dial bore gauge, or not dial bore gauge, but the dial snap gauge is what this is, the dial snap gauge. Let's see where we are on here. Okay, that's not going to show up very good unless I point it up. Okay, we'll check at 120 degrees, okay? So I'm just going to roll this back. Okay, moving 120. I'll get it in a good spot here. Roll it back. Okay, it's zeroed right there, pretty good. Okay, moving 120. Like I said, it's a lot better to check this on a surface plate. But we're doing a field check here, right? Oh, it's kind of creeping off that zero there. Let's see where we are here. Okay, this is what I found. Is we're off 100 millionths of an inch. Now, there could be reasons for this too. And one is a 3-jaw chuck is not very solid, okay? So what I'm gonna do is I'm gonna take this piece out of this chuck, put the 4-jaw chuck on, and take another cut on this piece with the 4-jaw. Now, we're gonna check something else. How much taper do we have here? See, we have a full thousandths of taper and just about 2.5 inches. A thousandths and a tenth, huh? See that? That's fairly normal too. Now we're going to play around and see if we can reduce that. Okay, now I'll be back. So I snugged up the rear spindle bearing just a little more. Now I'm very conservative on adjusting these spindle bearings because they're so expensive. I consider them not replaceable. So I'm going to run this in a little bit. We'll take a cut on that piece of steel, run it in the 4-jaw chuck. Looking at 1,127 RPMs and 2.7 thousandths speed, and probably I'll go about 5 thousandths depth. Okay. Okay, I'm going to attempt to use a dial indicating snap gauge with the camera in front of me, and so you can see and I can see, and let's see how that goes here. Okay. Now I'm going to rotate this chuck and we're going to check this piece of work here, okay? Okay, we're at 0 there. And I'm going to rotate this chuck, about 120 degrees. I'm going to check it again. Oh, these things are so touchy. Let me get it on there. Get it settled in. Well, it's not cooperating. I don't see it. Doesn't feel square. It's feeling good. Yeah. Okay. That looks pretty good. Get another 120 degrees or so. Now the gauge will kind of burnish itself in there. I'm rocking it back. Okay, it's reading just about 25 millionths above 0. I'll rotate it again. See where we are. That's about 25 millionths of 0. Try it again. Now it'd be more accurate to check this out on the surface plate, of course. Let me get this over here a little bit. Make sure it's not on a burr or a piece of dust. Walk it over. Oh, there, it's feeling a little better. Oh, about 25 millionths above 0. Check it again. Just check it a few times here. There's a little shoulder here, and I gotta just have that anvil clear of it. Well, I'm not doing a very good job of holding this. Ah, that looks good. I think we're within 50 millionths because it's going about 25 over and 25 under. So that's about par for the course for Timken bearings. Actually pretty good. But I'll keep, I want to run the lathe some more, and then I'll do a test piece in tool steel and get a little better finish on it. Use Micro 100. This one here, I just used a, I guess it's an ACT standard brazed carbide AR8 tool. And I put a 20 thousandths radius on it. And I found that running at top speed 1127, I was getting over 100 millionths out of roundness. This is rotational accuracy. So we got the rotational accuracy using a 4-jaw chuck and a speed down from top speed, which 849 RPMs. This machine will put out better than 100 millionths rotational accuracy. That's a dimension not talked about a lot, and it has nothing to do with the spindle mills. It has to do with the bearings and how round a part actually is. Okay, now on the Monarch 10EE, it's got a ball bearing spindle, and ball bearings are inherently more accurate, for rotational accuracy. But you have to do the same things there to get a more solid grip. And one of the things that with that 3-jaw chuck is that it's not balanced very well. I can feel it through the lathe. This old 8-inch 4-jaw, I statically balanced it. And I'll statically balance the 3-jaw 8-inch Cushman, and I think that will help that a little bit. But if you want the most accuracy out of this machine, the way it's sitting right here is with this 8-inch chuck and a 1 speed down from top speed. So I'm kind of finding the parameters of this machine, and that'll give me an idea of what I can do with this machine for bearing work. Okay, I hope you enjoyed this. I'll see you soon.